Right on time. Okay. Hello, folks. Good morning.
Woo!
And
I love you, Atila.
as Teja said before, this is my second time here, and this is one of the best conferences I've ever been in my life, and it just keeps getting better. So another round of applause, please. And thank you all for being here. So I was talking yesterday with Andre. I didn't see him today, but he's somewhere around. The other Andre, yeah, there's more than one Andre, but yeah. And he told me that a very big challenge that I would have in this talk is to get you not to think about food, because I'm the last talk before lunch. So I think the best thing to do is not a threat, but this is a security talk. You stay here or you'll get hacked. Not a threat, but I'm watching you. No. Yeah, so anyway, so the important thing about security is that it needs to be in depth. As developers, we're trained to think about the whole dry codes thing, don't repeat yourself and stuff like that. But for security, redundancy is okay. It's even advised, I would say. And I like to think about security in 3 steps. The first one, yeah, we have to prevent the leaks, right? We cannot allow sensible information to be exposed to other people. When especially, like, depending on what kind of app, this gets more important, or yeah. And we need to limit access, so it's good, advisable, to, when you're dealing with sensible information, you only give access to people who need to have access to that sensible information. And as a last step, which is the most common one because that's the one that's entertaining in movies, is to actually shield from attacks. So, but you cannot have 3 if you don't have the 2 before. So I'm gonna talk, this talk is more aimed about, it's entitled Security First Web Apps, because in my experience, we are evolving as an industry. Like in the very beginning, if you're old enough, you remember where accessibility was kind of an afterthought, nice to have, and right now, we finally got to a point where apps that want to be taken seriously, apps that want to be good, consider accessibility paramount aspect of user experience. Then we got to performance, where thanks to e-commerce, people start paying more attention to it. It is important. It costs money to not be performant these days. But security is still kind of an afterthought in most cases. It is, though, a lot of the measures that I'm going to show here are things that you do once and you don't need to do again. So that's why I entitled it Security First Apps, because if you do that in the get-go, it's kind of easier for you to get things done the right way and not worry about that anymore. One thing is HTTP headers. In most cases, you're going to do that once, and then a few of them, you need to consider them if you're adding features or if you're changing something, but more often than not, you don't. I'm not gonna bore you to death by explaining each one of them what they are. All of them have very good MDN entries, but the titles are more or less self-explanatory. And yeah, so I'll skip to the 3 that I find either most important. First, for the effect that they have on your application. Second, or because of the consequences of not having it properly set. So the first one is strict transport security. And it is meant to enforce HTTPS. HTTPS is going to ensure that the communication between your client and the server is encrypted. And the strict transport security is going to tell on the HTTP header, this website wants to be rendered only in HTTPS. The second one is the X content type options, which is a mouthful. It is about preventing browsers from sniffing the meme type of a file that they're receiving. And this was supposed to be a feature, I guess, in the beginning, where browsers wanted to be helpful to people, to developers, by defining the type of the file based on the contents, which means that that ended up opening up for people with bad intentions to send files that with a harmless meme type or MIME type, harmless one, like text, for example, but it was actually an executable or a script. So this header tells the browser that your domain doesn't want the type to be sniffed. So either you declare the right type or you don't. And the last one is important if you're dealing with some kind of hardware integration. This header is going to tell which APIs have permission should be requested by the browser. And the strict transport security has another nice feature that can be done. Once you set it up properly, you can actually instruct the browsers to preload it. So if somebody tries to render your website on an HTTP, if it's not preload, then you're going to have one round trip that is not HTTPS. And by having it instructed in the preload, what happens is that internally the browser can then replace that call from HTTP to HTTPS from the get-go, so your server never gets a non-secure connection. The way that the preload list works is through this website. So first, there are a few guidelines that you need to do. The website is very nice in explaining what to do, and even the trade-offs, like not every time you're going to want that set up. So there are all the trade-offs there, it's all nice, and once you set it up, this list gets shipped to most major browsers. And then your domain is going to be there, and so on. And actually, let me show you this. I need to exit the presentation. Oh, I need to exit the presentation. So the website, actually, they suggest this stuff, and you can actually have in this form, which is a submission form, it's going to tell you the status of your application, if it's already in the list, and if it can't make it to the list, it's going to tell you why. So it's pretty helpful to have that. I totally recommend if you can have it. It's not for every kind of app, because you need to include the subdomains and so on. So some apps, depending on their complexity, they cannot have that. And let me put my clicker back on. And then after that, another header that even got their special little section on this talk is the content security policy, which in my opinion is the most important for you to have to secure your application. It is, though, very annoying to set up. Not because it's complex, but because it's very easy to mess up. First of all, the content security policy is actually two headers. You can have the content security policy, which will block anything that violates their directives, or you can have it as a report only, which is then not going to block. It's going to put a warning in the console, but it also has one of the directives is a report URI, and then it's going to push to a certain API of your choice, of course, what was the offense and that it would have blocked if the header was the one that blocks. And the reason why the report only is important and having the report URI is important is because there are a lot of browser extensions that mess up with that. Not only ad blockers, though ad blockers do that a lot, but many browser extensions. So there is a lot of false positives related to that, which brings me to the next point of CSPs. You have more than one way to set it up, and they don't work the same way. The easiest way to set up as a front-end developer, which I imagine most of us started as at least, is with the meta tag. So you can set it up in a meta tag, and you pass in the content of the meta tag all the directives, which are actually a lot. Luckily, they have the default source, where basically the most important ones, if they're not set explicitly in your directive, they are going to inherit the default source. The problem with this one, though, is that it lacks a few features. So for example, the report URI, so if something gets blocked, if something offends your, even if it's a report only, which it's not going to be reported anywhere, though. So there's no way of you to know how disruptive is being the experience of your users by your CSP. The other thing is that you cannot use the frame ancestors directive. And the frame ancestor is going to control which origins are allowed to render that website. So basically, they can put your iframe somewhere else, and that's a very common technique for something called clickjacking. So they can actually mimic your website and put something else there and so on. So you cannot have that with this security policy. The other thing is, because it's an HTML, it only works for that specific document. So you need to then actively set up in all routes of your app. And the other thing is, because it's HTML, your document needs to be loaded and parsed before it takes effect. So there is basically a period of time where there's nothing working. So the CSP is an HTTP header. It is a backend responsibility. We need to set up as the header on every request. The reason that we have the HTML tag is basically as a fallback, okay? So that's essentially it. If you are only a front end and you want to introduce CSP, you need to talk to whoever is serving your app, whoever is responsible for serving your app. And then there's another step that we can do to make it even more ironclad with our CSPs, which is adding a nonce. A nonce is kind of like holder. Nonce is number used only once, and then it was too big for people to repeat it, and then number once and nonce in the end. Okay, so that's a nice way for you to remember it. And a nonce is basically a randomly generated hash that it's going to ensure that, first of all, that script that you're linking or that resource that's linked on your document is fresh. The second of all, it's something that only your backend is going to know about. So by adding the nonce in your CSP, it means that your app is only going to allow resources that have the nonce added. So this basically prevents most kinds of man-in-the-middle attacks and most kinds of cross-site scripting. It is, though, a little bit tricky to set up because, first of all, it needs to be entirely random. If you have it being enumerable in any kind of way, somebody can find that out. So it needs to be random. And it needs to be set for every request. It cannot be, of course, always the same, because if you have the same nonce for 2 requests, somebody can exploit that. So it is a little bit tricky to set up. But then once you add it to your CSP, and you can add it to different directives, you can add it only for styles, you can add it only for scripts, and so on. Then it's going to start blocking for everything. And it's pretty nice the way that the browsers behave with that. Like if you try to, even if you're trying to look at inside the DevTools, they're not going to actually show you the hash, but it's a sign that it's working. It's usually prefixed, it needs to be prefixed with a nonce. But yeah, I'll get to that in a minute. And then the last thing that you need to do, especially if you have an interactive app, is cross-site resource forgery, which is the name of the attack, and it's a mouthful, so we just say CSRF. And you can add CSRF protection in two different ways. One of them is significantly easier to do than the other, and it works like in most cases. So you have the refer-based and you have the token-based. The token-based is basically, first of all, the CSRF protection is only for requests that will update data on your server. So if you think about the HTTP verbs, it's the post, put, and delete. So you don't need CSRF for get. If you do change data on the server with a GET request, please don't. So yeah, the token base generates a token that only your server can validate, and based on that, it defines it's a legitimate request. The refer base is much easier to do, and you can set that with a middleware that actually fits in a slide. So what we do here is, first of all, if it's not a GET, if it is, we only do the check-ins if it is a GET request, right? Then we find out what is the origin header. And this GET header, what it's doing is basically getting the request object and getting the origin. The origin is roughly a new header. So if you need to support browsers that are a decade old, you can fall back to the refer. Most likely this is going to work. My hot take is that if somebody is using a 20-year-old browser, you don't want them messing up with your server anyway. And then it checks the host header, which is the domain the request is coming from. So based on that, what you need to do later is just verify the request origin, and this code has a little bit of this helper because it's a actual used code, and there is a possibility that you might want to have an allow list for external domains, external hosts that you would accept. So not necessarily, though 99.9% of the cases, what you want to do is make sure the origin and the host are the same, but there are like a few cases where you might want it to allow other people to do. And as I said, this is real code because after realizing that all of these headers, all of these things are stuff that I want to do on every app that I ever created, but I also wanted to not have to write everything again, all in all, because I'm lazy, I guess. I figured, okay, I need somebody to shield it, and I like Vikings, so I called it Shield Wall. And what it does is it adds the CSRF protection, that code that I just showed you. It adds all the security headers with sensible defaults, and it helps you setting up the CSPs in a way that typos are not going to break it, because there's a bunch of directives, and if you remember from that HTML tag, it's like a content. It's just a huge string that gets concatenated multiple times, has a few weird keywords like inline, self, and etc. And setting up the nonces, concatenating with those strings, is literally very annoying to do. So I said, okay, I'm going to do this once, and that's it. So basically, that's it. Unfortunately, at this point, it only works for the start frameworks, which is solid start and 10-stack start. But I do want to make it agnostic one day. The way it works is like this. So this is kind of Nitro code, but it's a little bit abstracted away. So Nitro is this Node.js runtime. It has a similar syntax, sort of, to Express. And this is essentially like a code that you can write on a solid start app to create a middleware. So there are two kinds of middlewares on Nitro that also applies to Nux, but Nux uses their own syntax. So you have the on request and the on response. What you want for the security headers is to have that on the request. And then basically what I do is, in this create middleware, what you get is an array where it's going to determine the order of execution. So I do first the CSRF, because if it's a post request, I want to block it as early as possible before doing anything else. Then I pass the security headers, which is basically just appending that all those headers that I want with the default values to my request object, and then the CSP. And as you can see, the CSP gets a little bit tricky because I want to extend I created templates for them. So I have the production one, and there's a dev one, because if you set your CSP from production to your development app, hot module replacement is not going to work. So you can have it two ways. You can have the dev only CSP if you want, or you can also set the production. Then when you're not in the production environment, you can set it to report only, and then it's going to pollute your console log with all the things that's going to be blocked, but it's going to work nonetheless. Same applies to the nonces. You don't want to have nonces on your development stuff because it's not going to work with the hot module replacement. And then on top of those that extend, you can then add your own values. So in this case, this is a bogus example because I'm just replacing the iframe source to self, which is the default value anyway. But I wanted to show you that you can do this kind of stuff programmatically as well. But then, as I mentioned, like CSP is a very disruptive thing for your app. So what happens though is that once you set it up once you're able to turn it on the blocking, let's say you have now a new external script, like I don't know, let's say Google Tag Manager, right? Who never got a script from a Google Tag Manager that you need to add it on a running app, right? So for that, you need to update your directives. You have, the way you can do it is if you are very brave, bold, and a little bit reckless, you can just add the domain and make sure you trust that. If you are even more reckless, you can put your CSP back into report only, go blank and do the changes you need. Or you can even declare two CSPs in your app. So in this case, let's say I want to, I ship the CSP as quick as possible, so no nonces, because they are the ones that block the most things. And now I want to add nonce. What I'm going to do is declare a second one as a report only, because they're separate headers. So you can have one that has the default and another one that has the changes you want to do. So the first CSP is going to add the nonce, but it's also going to only collect reports. So that allows me to run that for like a week or so, while my users are still protected as they were before, but I'm collecting all the errors from the nonces being blocked. So if some key users have a specific browser extension that's going to be blocked, or if there is something else that's, I don't know, somebody added a different script on the Google Tag Manager and now it's getting blocked, that one would get blocked as well. That's how it goes, and so on. So that allows you to easily identify if you want to add it or not. So basically, this, if you are using one of the start apps, this is ready to be used. You can just add it and use it like that. And that's it for the headers. So, but there is another thing that is very dangerous for us JavaScript developers, because we love node modules, right? And please raise your hand if you know every package that is in your node modules. Yeah. So we had, about a few years ago, an incident that I like to call left pad gate. Some of you might be old enough to remember when this happened. I was there. So when JavaScript developers learned about supply chain attacks. And actually, nothing that dangerous happened. What happened essentially is that, oh yeah, on March 2016, a developer got into a dispute with NPM about some other package that they have, and NPM didn't have a satisfactory answer to them, and they said, okay, I'm going to unpublish all my stuff. Happened this little package that has 11 lines of code. 11 lines of code, but it was used by things like React and Babel. And I'll let you all know, if anybody doesn't know that, you have Babel in your code base, in your app, right now, today. So everybody uses those apps. And what happens when a package gets unpublished? They're gone. Every build was broken for a few hours or a day, I don't remember. And that left JavaScript developers very angry. So what NPM did is it snapped it back into place. So put left pad back and said, okay, nobody can unpublish their stuff anymore. Because what happens if, during that time, if somebody unpublishes a package, and at this point, all our builds just got broken, but what happened if somebody saw that left pad was gone and it was used by the entire JavaScript community and put it, and put like an executable, anything malicious there? So that's what's called a supply chain attack. And so we started getting more cautious about that. One thing is, what I already spoiled it, NPM blocked everybody from unpublishing a package now. So that's going to prevent. So if you have what you can do to make sure your build doesn't break if somebody goes nuts on a package is locking it to a version. If you're using a certain version that is published, you're going to be able to use it forever. Another thing that raised our ears about that is about post-install scripts. A lot of packages use post-install scripts. Like, for example, Sharp is a very common one for optimizing stuff. ESBuild and Parcel do some post-install scripts. And I think PNPM is the only package manager that blocks install scripts by default. What you can do is run this command, so approve builds, and then you can select from all your package in your module the ones that have a post-install script. And then what's going to do is it's going to append a new key to your package JSON, and it's going to say, yeah, these packages are allowed to run it. So it is sort of a controversial change because it doesn't fully protect, but it does deters some issues. Yeah, and in the case of ESBuild and Parcel, what they do is mainly for optimizing some dependencies inside your managers for the build time. So if it's been blocking for you and you didn't know about that, that's fine. It still works the same way as it should, just slower. Yeah, but the other issue though is, as you might imagine, the more script executions that we have, more supplying attack vectors we have, which means that they, whoever they are coming for your CI. Because now we have a lot of, like, with GitHub Actions at least, I saw that happening way more often. We run a lot of stuff in our GitHub Actions now. And one thing that we can do to prevent that is hardening our GitHub Actions. The way we do that is appending the commit hash to the GitHub action that we're going to include in our stuff. So like, for example, if you're going to use the action checkout, which all of you use, you can then append the hash for that. But as I mentioned before, I am incredibly lazy, and going one by one and finding the right hash and putting there is very annoying. So here's a curl command that you can get it for you. You just add then the user and the repository and the tag you want. There's even a little shortcut if you just want the latest one. And this snippet gets shorter if you have the GitHub CLI, which is very useful, by the way. You can do that, and that's going to append, it's going to return the SHA of the commit that you want to do, and then you can just add it to your GitHub Actions, and you're safe. So, okay, we have about 2 minutes, and let's do a quick recap of the highlights of this thing. First of all, we need to first prevent leaks, then you need to limit access to private sensible data, and last of all, we don't want to be attacked, of course. The HTTP headers that you need to allow, and a lot of them you see are redundant to the CSP, but as I mentioned, redundancy is good, and no app is going to get bloated by HTTP headers, I guarantee you. Then we have the CSRF protection. Token-based is safer because there are ways to bypass the refer-based one. It can be bypassed, but for most apps, refer-based is okay, and something is always better than nothing. Then the content security policy needs to be used as an HTTP header, and try to use the nonce as well. And lastly, you want to harden all the CI call, all the dependencies in your GitHub Actions and CI with the SHA commit. But most importantly, and the thing you can never forget on web development, is to try to have some fun anyway. So thank you very much, and I'm not going to keep you for the food anymore. Woo!